Gauss divergence theorem. Let us see the example. Verify Gauss divergence theorem for capital F vector is equal to 4xz I vector minus y square j vector plus yz k vector over the cube bounded by x is equal to 0, x is equal to 1 and y equal to 0 and y equal to 1, z is equal to 0 and z is equal to 1. So this is the question. So here the cube is given, so therefore the Gauss divergence theorem is double integral f vector dot n cap ds, which is equal to triple integral del dot f vector into dv, So this is the formula for Gauss divergence theorem. So let us solve left hand side first or right hand side first. So I am going to solve right hand side. So what is the right hand side? Right hand side is triple integral del dot f vector into dv. Okay. So del dot f vector first you have to find. So del dot f vector is equal to, del means I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Okay, this is a del. Dot f vector is given in the problem, 4xz I vector minus y square j vector plus yz k vector. Okay, so del dot f vector is equal to, which is equal to del dot f vector, which is equal to I vector dot I vector will be 1. So dou by dou x of 4xz plus dou by dou y of minus y square plus dou by dou z of yz. Okay, so you have to differentiate these all. So if you are differentiating, del dot f vector is equal to del dot f vector, which is equal to dou by dou x of 4xz will be 4z, dou by dou y of minus y square will be 2y, minus 2y, plus dou by dou z of yz will be y. So del dot f vector is equal to 4z minus y. This is the del dot f vector. So next the triple integral, right hand side, everything is given, triple integral 0 to 1, 0 to 1, 0 to 1. So del dot f vector is 4z minus y into dz dy dx, or else you can write as dx dy dz. So therefore, which is equal to integral 0 to 1 4z. So 4 z square divided by 2 minus zy. With respect to z you have to integrate. So dy dx. Okay. So for z you have to apply 1. So therefore which is equal to integral 0 to 1 4 by 2 minus y. You have to apply for z1 dy dx, which is equal to 4 by 2 is 2. So integral 0 to 1 integral 0 to 1 2 minus y into dy into dx 2 minus y, which is equal to integral 0 to 1 with respect to y you have to integrate, so 2y minus y square by 2 0 to 1 into dx, which is equal to integral 0 to 1 you have to apply for y 1 2 minus 1 by 2 into dx, which is equal to 3 by 2 integral 0 to 1 into dx, 3 by 2 integral 0 to 1 into, right, dx. So therefore in the next step you can write as, which is equal to integral 0 to 1 2 minus 1 by 2 3 by 2 2 minus 1 by 2 3 by 2 into dx, which is equal to 3 by 2 x, limit is 0 to 1, which is equal to 3 by 2 for 1 x, for x you have to apply 1, so 1 minus 0, so 3 by 2 1 minus 0, which is equal to 3 by 2. So answer is 3 by 2. So right hand side answer is equal to 3 by 2. So next you have to find for left hand side. So left hand side is, you have to draw the cube. So cube, if you are drawing, so here you have to draw the cube, x axis, so y axis, z axis. So therefore x axis, so y axis, so z axis. For x axis, in x axis 1 comma 0 comma 0, in y axis 0 comma 1 comma 0, in z axis 0 comma 0 comma 1. Okay, so a, this is origin, so a, b, c, d, so every corner you have to name f, g. Okay, so this is very important. So how many faces are there? There are 6 faces. So you have to take the 6 faces to find. So therefore the left hand side is single integral, right? So single integral we are going to find. So single integral is, here is the left hand side is double integral f vector dot n cap ds, double integral f vector dot n cap ds. So which is equal to how many faces? 6 faces, s1, s2, s3, s4, s5, s6 plus s6. So 6 faces there are 6 faces. So you have to find the 6 faces. So first face is O, right, A, B, C, D. This is one face, A, B, C, D, right, A, B, C, D. So this is one of the face. In this face, what is n cap? N cap is equal to I vector. Okay, what is the ds? X is equal to 1. ds is equal to dy dz in ABCD. The opposite of ABCD is O, E, F, G. O, E, F, G. This is the n cap is equal to minus I vector. X is equal to 0. ds is equal to dy dz. Okay. So next one is y axis. In y axis, E, F, C, B. So n cap is equal to j vector. So in j vector, what is y? Y is equal to 1. ds is equal to dx dz. Next opposite of y axis is O, G, D, A. So O, G, D, A. N cap is equal to minus j vector. So y is equal to 0. So ds is equal to dx dz. ds is equal to dx dz. Okay. So next one, z axis, CF, GD. n cap is equal to k vector. So z is equal to 1. ds is equal to dx dy. Last one is OA BE. This is n cap is equal to minus k vector. Z is equal to 0. ds is equal to dx dy. Okay, ds is equal to dx dy. So these 6 phases we are going to find the value. So 6 phases value we are going to find. So first phase 1. So S1, which is equal to, first one is phase 1, S1. So S1 is equal to, or else on ABCD. So ABCD phase S1, which is equal to double integral f vector dot n cap into ds, which is equal to double integral, what is f vector? That is given in the problem, 4xz I vector minus y square j vector plus yz k vector. This is f vector dot n cap I vector into ds dy dz, which is equal to I dot I will be 1. So therefore double integral 4xz dy dz. So what is a 4xz dy dz? For x in ABCD, x is 1. So double integral 4z dy dz. The limit is 0 to 1, 0 to 1, which is equal to integral 0 to 1 4z dy. If you are integrating y, the limit is 0 to 1 dz. So if you are integrating dy, you will get y. So therefore apply upper limit as well as lower limit. 1 minus 0. 1 minus 0 will be 1. So 4z dz. If you are integrating this, 4z square divided by 2. Z, if you are integrating, z square divided by 2, which is equal to, if you are applying upper limit, 1 by 2. If you are applying lower limit, 0. So 4 by 2, which is equal to 2. This is one of the answer, first phase. So next, second phase. So second phase is, second phase. So here you have to take OEFG. OEFG, double integral f vector dot n cap ds, which is equal to f vector. What is f vector? 4xz I vector minus y square j vector plus yz k vector dot f vector dot n cap ds. So dot k vector dot minus I vector into dy dz, into dy dz, which is equal to, minus I vector means double integral 4xz minus 1, I dot I will be 1, dy dz. What is the x in OEFG second phase surface? 0. So the answer is 0. So next, third one, phase 3, EFCB. In this phase, double integral f vector dot n cap ds is equal to double integral 4xz I vector minus y square j vector plus yz k vector dot j vector into dx dz. So what is a j vector? J vector dot j vector will be 1. So double integral 4, here is a minus y square, not 4x. 4x is I dot I j, I dot j will be 0, j dot j will be minus y square, j dot j will be 1, k dot j will be 0. So 0. So therefore dx dz, dx dz, which is equal to double integral minus y square into dx into dz. What is y? 1. So double integral minus 1 dx dz. If you are integrating dx dz, double integral, the limit is 0 to 1, 0 to 1. That is given in the problem. 0 to 1 minus x. If you are integrating dx, 0 to 1 dz. 0 to 1 dz. So which is equal to, if you apply the limit minus 1, so 0 to 1 minus dz. If you are integrating it minus z, the limit is 0 to 1. So answer is, which is equal to minus 1. So this is the answer for third one. Next, we are taking fourth one. So fourth one is OG DA space. Here double integral f factor dot n cap ds is equal to f factor dot n cap ds is equal to, what is the double integral f factor dot n cap? So 4xz double integral 4xz I vector minus y square j vector plus yz k vector dot, so OG dA, so minus j vector into dx dz. So minus j vector, I vector dot j vector 0, j vector dot j vector will be 1. So 0 to 1, 0 to 1 minus y square minus j vector, so y square dx dz. So what is y in OGDA? 0. So answer is 0. Y is 0. That's why answer is 0. So fourth one, CECF GD. In this surface we are taking fourth surface. So here if you are taking in this fourth surfaces, you will get double integral f factor dot n cap ds, which is equal to double integral 4xz I vector minus y square j vector plus yz k vector dot yz k vector dot k vector into dx into dy. So therefore k dot k will be 1. So double integral z is equal to 1. So yz dx dy, which is equal to double integral 0 to 1, limit is 0 to 1, z is 1. So y dx dy, okay, which is equal to integral 0 to 1 y dx. If you are integrating x, limit is 0 to 1 into dy. So 1 minus 0 is 1. So 1 into y. So integral 0 to 1 y dy. Y dy, if you are integrating, you will get y square by 2. Limit is 0 to 1, which is equal to 1 by 2. So this is the answer. Sixth one. So sixth one is on OABE. Here z is 0. So therefore double integral f factor dot n cap ds is equal to double integral 4xz I vector minus y square j vector plus yz k vector dot minus k vector into dx dy. So minus k vector will be yz. So double integral, what is z? 0. So yz into minus 1 dx dy, which is equal to 0. Why? Because z is 0. So every surface we have got the value. Now we have to add every surface value. So double integral f factor dot n cap ds is equal to double integral s1 surface 1, double integral surface 2, double integral surface 3, double integral surface 4, double integral surface 5, double integral surface 6, which is equal to 2 plus 0, right, minus 1 plus 0 plus 1 by 2 plus 0. So which is equal to 2 minus 1, 1 plus 1 by 2 is equal to 3 by 2. This is left hand side. Already we have got right hand side which is equal to left hand side which is equal to 3 by 2. So hence verified.